guys, Mr. Coring here, Hutchinson High School. Today, I'm going to teach you about our next welding process, which is Oxy-Fuel welding. It's going to be awesome. It's a great precursor to TIG welding, and I can't wait to get started.
Oxy-Fuel welding is a mixture of a fuel source and oxygen that creates a really hot flame that allows us to melt metal and weld it together. It's a very old process. This process requires no electricity, just a fire tetrahedron. So the fuel we use is called acetylene. Right there, as you can see, acetylene. And here is oxygen. These are some different attachments you can have with the Oxy-Fuel torch system. So this is a cutting torch used for cutting metal. These two are two different sizes of welding heads. We, in Welding 1 class, are going to do some Oxy-Fuel welding. And then this is called a rosebud. Here's going to be the metal that we practice our welding on. We have two fire bricks here to keep our metal up off the table and help absorb some of the heat that we use. It's going to be stored over in the corner by the eye wash station. So anytime you're going to do anything Oxy-Fuel related, welding, cutting, heating, make sure you have fire bricks. This here is our torch body. So the torch body is what we connect our attachments to. So here I have a number 7 welding head for you to see. Smith 07. So different sizes are all for the different diameter of the hole in which the flame comes out. So bigger the number, thicker the metal you can use. So we have what's called quick connect changes. These are Smith torch bodies. So what happens is I can put my welding head in just like this, thread it on in, finger tight, and voila, it's that simple to set up. So anytime I can change back and forth between cutting, welding, all that stuff, it can happen really, really quickly. You see down here, we have the two hoses. Red is for acetylene, that's our fuel source. Green is for oxygen. Those two have to mix in order for us to have our proper flame. Torch body, we always have to make sure that these valves are closed when we're all done. Reason is, when we open up our bottles, if those are open, you'll start hearing a gas leak out, and that's a waste of gas. And especially if it's our acetylene, that's a flammable gas. And if it's anywhere near an ignition source, it could create an explosion, which we do not want to do. So always make sure these are closed.
So to get started with our Oxy-Fuel torch, we have to get our bottles opened up, set our pressures to where we want them. Then we can start working in welding, working in cutting, working in heating, depending on what our application is. For our Welding 1 class, we're going to be working on welding, and we're going to focus on that to start. So with our system, we always want to make sure that there's no pressure on our lines to get started. I will show you how to bleed those and shut those down at the end of the video, but make sure that there's no pressure on our system when we get started. You'll do that by reading our gauges. Both gauges should read 0, and I will show you how to do that at the end. So when you start and you have both gauges reading 0, you want to make sure that regulators are threaded out. Regulators are what set and determine the pressure. Then we always start with A before O. So A is our acetylene, A becomes before O in the alphabet, and we'll do that for each process. That's going to help keep us safe, because if these two pressures are not set right, this could turn into something very similar to an exploding bomb or something like that. So we don't want that to happen. So we're going to start with our A, our acetylene. That bottle, we only quarter turn open. So it goes from closed, spin it 90 degrees, so it's open. We only open it just a little bit, so that way if something bad goes happen, fire, explosion, anything like that, we can quickly turn it off to kill the fuel source. So once that is open at a quarter turn, then I'm going to come down here to my regulator. So I thread my regulator in to the right, because righty tighty, lefty loosey. At the end it should be all the way threaded out, until my gauge is set to 6. So for the acetylene, we always use 6 psi. Now, depending on what you're welding, what you're doing, these pressures can change. There's all sorts of charts online and everything like that. Just for a general rule of thumb, we always set it to 6, and that gets us pretty close to where we need to be.
So as you can see, regulator plus, that adds pressure. And then we have it set to 6 psi. Note that psi is the inside number, so we have to pay attention to that. Bar is on the outside, and that's very important, especially when we get to the oxygen. So now this is set up. Now I'm ready to turn on my oxygen. So now to set up our oxygen, we have to make sure our regulator is threaded all the way out to the minus. So that's to the left, okay? It's very important that we have this right. If you thread them all the way the wrong way, when you open the bottle, there's gonna be enormous amount of pressure on these lines, which could cause an explosion, which we do not wanna do. So we have our acetylene already set. Now our oxygen, we're gonna open up all the way. Make sure that this is your cylinder gauge. Cylinder gauge has a needle that goes up. That means there's pressure in the cylinder. If you ever open the bottle and this needle doesn't go up, that means the bottle is empty and we have to change that out of the gas cage, okay? Now, look at our line pressure gauge. Note we are setting it to PSI. PSI is these little numbers right in here. So if you look, if the needle doesn't move very much, that goes to 50 PSI. The outside number is bar. That's just a different source that we are not going to deal with. We are dealing with PSI. So it's very important that we set that up. The biggest mistake I see people make is when I tell them to set it to 10. They set it to 10 bar, which is 150 PSI. That's problematic for us getting our torch lit. Plus it puts a lot of pressure on our lines, which we don't want to do. So what I'm gonna do is I'm gonna come back. I'm gonna thread this up to the right. So you can see. All right, so I'm gonna come back. What I'm gonna do, I'm gonna set this up. I'm gonna thread it to the right where it says plus, and I'm gonna move that till we get 10 PSI. 10 PSI is right there, just barely up off the side. That way I know I'm ready. So now that I got my line pressure gauge set to 6 for my acetylene, and got it set for 10 for my oxygen, now I'm ready to head over to the torch. So here's my torch. Again, I have my welding head here. I said we were gonna be doing our Oxy-Fuel welding and welding 1. I wanna make sure that both of my lines are shut to begin, and then we'll be ready to open the valves and start welding. I'll show you how that process goes. I got my pressure set on my 2 gauges. Now I got my torch. So when we do Oxy-Fuel welding, how we set these up definitely matter. Different from cutting. Heating is very similar. So again, we go A before O, acetylene before oxygen. If you can't remember, red is fire, that's our fuel source, green is oxygen. So to get the flame lit, what we do, we quarter turn our acetylene open. You should hear a little gas hissing out. Okay? We're gonna light this. Once it's lit, it's gonna give an orange campfire looking flame. Once that flame is ignited, then we're gonna slowly mix in the oxygen. Slowly mix in the oxygen. Remember, righty-tighty, lefty-loosey. To open it, we have to spin it to the left, tighten it, we have to spin it to the right. It should be closed to start. Once it's lit, and once we start mixing in the oxygen, I'll show you, we're gonna go for a blue flame look, kind of like a gas stove. Make sure we always have our helmet, our safety glasses, our jacket, and gloves on when we do this. It's not as bright as a welding arc, but it's still pretty bright, and it can damage your eyes if you do it long enough. So you have a welding helmet or a green face shield, that'll keep your eyes safe from the arc. So I take a flint strike, just like science class. Now a lot of people try to hold it like this, try to light it with your thumb. Problem is, that doesn't push down on the actual strike pad. So I like to hold it overhand like this, and use my pointer finger to push down into the strike pad. See how I get a spark then? So, I'm gonna hold it here, about a couple inches away. I light it, now we have fire. So that's kind of an aggressive flame, so I'm gonna turn down my acetylene just a little bit. Turn down my acetylene just a little bit, so I get more of that campfire flame with that smoke coming out. That smoke's good. That's some carbon built up in the lines that we can burn out. Now I'm gonna slowly mix it in my oxygen. You see how that's that bluish flame? You get that white wing. You're gonna mix it in. Until you get one white streak, just like that, sticking out. That's what you want to be
when you do your welding. Okay? So now when we do our Oxy-Fuel welding, what we do is we put it down on the metal. Put it down on the metal, we put that white streak right on our metal, and we're gonna wait till it gets a welding pool established. You'll see it melt, just like if we're doing any of our other welding processes. Once it starts melting, then you can start pushing it along.
You get one white streak, just like that, sticking out. That's what you want to be when you do your welding.
Okay? So now when we do our Oxy-Fuel welding, what we do is we put it down on the metal. Put it down on the metal, we put that white streak right on our metal, and we're gonna wait till it gets a welding pool established. You'll see it melt, just like if we're doing any of our other welding processes.
All right, so once our flame's lit, what's gonna happen? We're gonna put it down on that metal, hold it at about a 45-degree angle, because we're always gonna push our weld pool when we do Oxy-Fuel welding. You wanna hold it pretty close, about an 1/8 inch from the metal, and you're gonna watch it heat up. See how it's getting orange there? Then what's gonna happen is you're gonna see it really start to liquid up, just like a weld pool. Once it starts to liquid up, then you can start pushing it along. I kind of like to go up and down a little bit or do some C shapes. You start to push that along, and that starts to melt the metal, okay? So this is a really old form of welding. It's been around for hundreds of years. And what's nice about this is the portability, the flexibility of it, and the fact that you don't need electricity. So it's really good out at the farm, stuff like that. So you just kind of push it right along, push that puddle, okay? And that's gonna make your Oxy-Fuel weld. So this here's what your completed Oxy-Fuel weld will look like. Know that it's very, 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 very hot. But do you see how you kind of got that weld bead there? Disrupt the metal and all that stuff. Because when we melt the two pieces of metal together, they actually start to shrink and warp. So when we do Oxy-Fuel welding, we add what's called filler rod to help offset that shrinkage and that warpage. Now, this is the same filler rod you use in TIG welding. That's what's nice about Oxy-Fuel welding. It's kind of a good precursor to TIG welding. So I'll show you guys what that looks like. My filler rod here, got my torch here. Let's do a weld bead with some filler rod. Close to close, quarter turn the acetylene, quarter turn the acetylene, leave the oxygen closed to get it lit. Once it's lit, oh, fire. And we slowly mix in that oxygen. Hiss a little bit, so we'll back her down just a touch. Get a nice good flame there. You really want to get it pretty long so that way there's a good amount of heat coming from this. So I got it right there. I got my one white streak. Grab my filler rod. Again, this is why we push so we can add the filler rod. So when we add the filler rod, we're going to add it to the actual weld puddle. We're not trying to melt it with this. We're trying to add it to the weld puddle. You guys will see what that looks like. So I get it here. Now it is a little hard to balance just using one hand, so you kind of just got to get comfortable. You get that weld puddle established, then you start adding that filler rod right to that melted weld puddle. All right. So when you're done again, A before O, turn the A, close the O. Now you're ready to go. Okay? When you add your filler rod, you'll notice it's noticeably bigger. Noticeably bigger. So if you take a look, our weld with filler rod. Do you see what that looks like? That's our Oxy-Fuel weld. Adding our filler rod right there. Doesn't look too bad, actually. Biggest thing is having your pressure set right, getting that heat, adding that filler rod right to the weld. So first thing we have to do is wrap up our torch nicely like that, making sure both valves are closed. That means spinning them to the left, so valves are closed, so nothing's gonna spin out once we're done. All right, now what we have to do is depressurize the lines of our bottles so there's no pressure sitting there when it's done. So again, we're gonna start A before O. So we're gonna close the bottle. Close it shut. Then we leave the gauges like this. Then you're gonna grab your torch. Grab your torch just like this. Okay? Now these should be shut. And now you're gonna do this. You're gonna slightly crack open the one that you're doing. So right now we're gonna do a settling because we're doing A before O. So I'm gonna crack that open. And you're gonna watch the gauges go to 0. Now there is no pressure on my lines, so it's gonna be safe. I close that back up. Now we're good with that one. After I close it up though, I have to thread out my regulator so there's no pressure when we turn the bottle on the next time. Thread it all the way out to the minus, so that way there's no pressure when we turn the bottle on the next time, and we can set that where we want it. Now we're gonna go up to oxygen. Same thing, we're gonna spin the bottle closed. Nothing with the regulator yet. We have our torch. We're gonna crack it open. And bleed the lines, you see that? So we cracked it open, bled the line. Now we're gonna spin it back to the right to tighten it down. We'll keep that wrapped up nicely. Last thing I have to do is thread out my regulator so there's no pressure on the tanks when we're done. Bada bing, bada boom. That's how you do some Oxy-Fuel welding.